I will write a program to determine if a number is palindrome or not. So what is a palindrome? A palindrome is a word, sentence, number, or character that spells or reads the same backward as it does forward. Now, an example of a palindrome number is 121 or 10801. So let's see how a program might deter if a number is palindrome or not. I like to demonstrate to you briefly. So let's take the number 1551. So the program would use a loop, and it would compare at once both the first digit and the last digit. So it would go from 1 at the start to the 1 at the end, and then it would move on to 5 at the start and 5 at the end. So at each comparison, it's taking a look at the first and the very last, and in the next time the program looks at the number, it goes to the second number and the second to last, and so on and so forth until it loops through the entire length of the digit. So I will be discussing two methodologies to write a program to do this. So let's get started. Okay. I have a function pre-written here. So my function palindrome, it takes in a parameter n, and it processes it to find a palindrome. So I have two conditions here initially, if and else if. So these are my base cases. Should the user pass in a number that is less than 0, which is basically a negative number, then we're going to announce it to be false immediately. Reason being is because negative number just don't qualify as palindromes. Because if you reverse any number with a negative, what happens is the negative comes after the number, and mathematically speaking, that's not how a negative number looks like. So if I have minus 121, the reverse of it would be 121 minus, and 121 minus doesn't read as negative 121. So for that reason, we rule out minuses. The next condition is else if n greater than or equal to 0 and n less than or equal to 9. And this condition takes care of any digits in the range of 0 to 9 that are only occurring once. So if someone just passes in one digit, well, the reverse of it would be only that. So that automatically qualifies it from being true. So for that reason, we have it bluntly stated as true. Now, I have here a variable n, and I have set it to n.toString. The reason being is because JavaScript doesn't process numbers to loop through. We have to convert the number to a string. Now I have a for loop here. I'm looping from 0, the first index, and then I'm going until the end of the string, or the size of the string, and then I'm going to iterate therefrom. So this takes care of both even and odd cases, the even length and the odd length respectively. So if the digit's length is 3, like 121, or if the digit length is 4, like 1, 2, 3, 4, it will address both of those lengths. So here I have the if condition. If n of I is not equal to n braces n dot length minus 1 minus I, then we return false. What that means is, if I have a number here, for example 144 1, what it means is if at my first comparison I would be comparing the 1 here at the start and the 1 here at the end. If they're not the same, then there is no need to look further. I would just pronounce the set of digits as false if they're not the same. If they are the same, then I would loop again, go on to the next number and check again if they're same or not. So if they don't happen to be the same until I check through the whole number, then I immediately say it is a palindrome. So let's run this code. So we get true and false respectively for the numbers 121 and minus 121. So in real time, how the program would run based on these numbers are, so user enters 121, it would go into the loop and it would look at at this condition. If the for loop, and it would check this condition, I less than n dot length. I is less than n dot length. I is 0 and the length of our given number here is 3. So it goes into the if condition. The if condition is basically the notation n of I, that is basically looking at the first element, which is 1 in this case. So if 1 does not equal to the last digit, which is 1 again in our case, then that number wouldn't be a palindrome. But in our case it is, because 1 at the start and at the end are the same. And then you have the 2, which is which reverses to the same place, the second place. So the next number, if a user enters minus 121, it goes into the if condition at the start, and that would be less than 0, so it would immediately claim it as false. Okay, so that's my first method. Let me comment this out so we can look at the second method. Okay, so here is my second method. Let's uncomment it. Okay. So I have another function here, palindrome 2, and it is similar logic, but just a little bit different in the latter portion. The difference is really here. So what we're doing is we're taking n, which is n dot toString, so whatever the set of numbers the user enters, we're just reversing it. So what we're saying is if n, which are the original set of numbers that a user enters, if that equals to the exact reverse of it, then it is a palindrome. Otherwise, it's not a palindrome. That's what we're saying here. So here is if n equals to the exact to its exact opposite, then it is a palindrome. So we return true. If it's not the case, then we return false, meaning that it is not a palindrome. So again, we check the numbers, save and run the code, and we get as expected. 121 is a palindrome, so true. Minus 121 is not a palindrome, false. Okay. So really the key takeaways from this view is that negative numbers aren't palindromes, keep that in mind, and single digits from the range of 0 to 9, meaning if a user enters only one number in the ranging from 0 to 9 and it's just one, if it's 1, there is nothing else for it to be a reverse other than itself, so that in fact would be a palindrome. And the third takeaway would be that we can actually improve the program by writing divided by 2 to our loop condition, which is I less than n dot length. That's what we have so far. If we divide it by 2, we only have to loop through the set of numbers halfway. And why this would be efficient is because by the nature of of the way we're looping through the first number and the last number in a given string of numbers that a user passes. So if we're doing that automatically every time we are covering two numbers, that is the first and last, second and second to last, third and third to last, and so on. So you've already covered the latter half anyway, so you don't have to loop through the entire thing. That would be redundant. So for that reason, we can just have our condition to reflect n.length divided by 2 here. Let's uncomment it. Just see it works. And let's comment this out because we're not using that logic here. So in the first condition is where we have this I less than n.length. That's what we had previously. Now we're gonna just divide it by 2, so that means in the given set of numbers it just looks through halfway. It doesn't have to look the other two numbers or the latter half, because we've already compared it. When we compared the first half, we looked at the first half with the second half, so we don't need to do it again. So I'm just gonna run it just to show. Oh, looks like we have a error. Missing slash line 30. Oh, I forgot to remove the comment line. Okay. Yeah, so true, false. So the main takeaway here is efficiency. So because we are looking at a set of numbers in pairs, that is looking at the first half with the last half as we're doing each iteration, looping through the whole thing doesn't make sense. So you just divide it by 2. So if I have 5 digits, I would just look at the 2, and then the last 2 are looked at anyways as I'm looking to the first 2. So it'd be not wise to look at the other half again. So I hope this makes sense. Should you have any questions or comments, please feel free to address them to me. And if you have any suggestions, generally speaking, I would love to hear them. I would love to have your feedback. Thank you.